Hello out there, welcome to this tutorial. In this video we'll be looking at mappings and functions. So we start with definitions. Given that x and y are non-empty sets, if there is an operation which associates every element x in x with a unique element y in y, such operation is called a mapping. The set x is called the domain, while the set y is called the codomain. The element y in y is called the image of x in x. A subset of y, which is a collection of the images of the elements of x, is called the range. This is denoted by these or days. In any of the three cases, f is a mapping from x into y. A function is a mapping whose codomain is the set of real numbers. Now, representation of mapping. Given x is a set of a, b, c, and d, y is a set of 1, 2, 3, 4, 5, and f is a mapping from x onto y. This is diagrammatically represented below. So we have the set a, b, c, and d, then set y 1, 2, 3, 4, and 5. So from here now, a is mapped onto 4, c is mapped onto 1, b is mapped onto 5, and d is mapped onto 2. You can see it is only 3 that is not an image in set x. So this is a diagrammatical representation of a mapping, and this method is called arrow diagram. We can write f of a is equal to 4, f of b is equal to 5, f of c is equal to 1, and f of d is equal to 2. And the r is all the elements in y that are images in x. So we have them as 1, 2, 4, and 5, with the exemption of 3. So that is all for representation of mapping. We go to one-to-one and onto mappings. Given f as a mapping from x to y, f is one-to-one or injective mapping if every element in x is mapped to a unique element in y. In other words, no element of y is mapped to by 2 or more elements of x. So what we are saying in this is every element in x has one and only one image in y. So there's no situation where 2 elements in x has the same and one image in y. So also f is onto or surjective mapping if every element of y is mapped to by some element in x. In other words, no element of y is left out. So in this case, the codomain is equal to the range. So every element of y is an image of at least one element in x. So in that case, we said the function is onto or surjective mapping. Then we say f is bijective if it is both one-to-one and onto mapping. So this is all we can say about one-to-one and onto mappings. So we look at zeros of a function. The zeros of a function are the elements of the domain whose images in the codomain are equal to 0. In this video, we'll be looking at how to find zeros of a function. So we are going to solve some problems. We take our first problem. Now for problem 1, if f of x is x cubed minus 2x squared plus 3x minus 5 is a mapping defined on the set of real numbers, find a f of -1, b f of 1, c f of 2. So we start from f of -1. So here, wherever we see x, we put -1. So from here we have -1 cubed minus 2 into -1 squared plus 3 into -1 minus 5. So -1 cubed gives -1. -1 squared gives positive, multiplied by -2 gives -2. Positive 3 times -1 gives -3 minus 5. So this is -1 minus 2 gives -3 minus 3 gives -6 minus 5. We have f of -1 as -11. So we go to b, which is f of 1. Also, wherever we see x, we put 1. So we have 1 cubed minus 2 into 1 squared plus 3 into 1 minus 5. So 1 cube is 1. 1 squared is 1 times -2. We have -2. This is positive 3 times 1 gives positive 3 minus 5. 1 minus 2 gives -1 plus 3 gives 2 minus 5 gives -3. Therefore, f of 1 is -3. Then we go to c, f of 2. So also we put x equal to 2 in this function. So we now have it as 2 raised to power 3 minus 2 into 2 squared plus 3 into 2 minus 5. 2 cubed gives 8. 2 squared is 4 times 2 gives 8. And 2 times 3 gives 6 minus 5. 8 minus 8 gives 0. And 6 minus 5 gives 1. So f of 2 is equal to 1. Then we are done with problem 1. We go to problem 2. For problem 2, study the mapping below and answer these questions. So the questions are: find the domain D, codomain C, and range R of the mapping. B, find the rule of the mapping. C, is the mapping one-to-one or an onto? Then we study carefully. In this mapping, X has the elements -1, 2, 3, and 4, and Y has the elements 7, 5, 3, 0, and -3. So we have already established in the beginning from our definition that the domain now is all the elements of X. So we have our domain as -1, 2, 3, and 4. Then also our codomain is the elements in Y. So we have a -3, 0, 3, 5, and 7. Now to get the range. Now we said range is a subset of the codomain, that is all the elements, the collection of all the elements in the codomain that are images in the domain. And if you study this very well, 0 is not an image in the domain. So all other elements are images of the elements in the domain. So those other elements will form the element of the range. So we now have it as -3, 3, 5, and 7. So we are done with problem 2a. We go to problem 2b. For problem 2b, f of x will be this is a linear function. How do we determine whether it is a linear function? It could be a linear function. Let's look at it as a linear function first, because there is no element in the codomain that is an image of two elements in the domain. So we look at it as a linear function first. So we say x plus 1. We start from x plus 1. If x is -1, this will give me -1 plus 1, which will give us 0. So it is not the rule. So we try x minus 1. So the first element here is -1. So which means if x is -1, -1 minus 1 gives -2. So that is not correct. We try then 2x plus 2. We try 2x plus 1. 2x plus 1. When x is -1, 2 times -1 gives -2. -2 plus 1 gives -1. Oh, that is not the rule. Let's look at 2x minus 1. 2x minus 1. When x is -1, 2 times -1 gives -2 minus 1 gives -3, correct? We can now go ahead. It might work for one element and might not work for the other element. We see 2 times 2 gives 4 minus 1 gives 3. Wow, that's correct. Then 3, when x is 3, 2 times 3 gives 6 minus 1, 5. Wow, so this is the rule of the mapping. So we write f of x is equal to 2x minus 1. Now we go to C. For C, is the mapping 1-to-1 or onto? Let's start from 7. 7 is just an image of only one element in the domain. 5 is an image of only one element in the domain. 3 also, and -3 also. Since every element in X is mapped to a unique element in Y, therefore the function is 1-to-1. So one element is mapped onto one and only one element. The other element is mapped onto one and only one element, and so on. So the mapping is 1-to-1, but it is not onto because the codomain is not equal to the range. So f is 1-to-1 but not onto, which brought the solution of problem 2 to an end. Then we go to problem 3. For problem 3, the set P containing -1, 0, and 1 and Q 1, 2 illustrated in the diagram below represent a mapping from set P into set Q. A. Determine the rule of the mapping. B. Is the mapping 1-to-1? Is it onto? C. Find the range of the mapping. we are to determine the rule of the mapping. So to get f of x, now this cannot be a linear function because 2 is an image of both -1 and 1. So something like squared must come in there, because -1 squared, 1 squared will give us the same value. So this is a hint. Then we now look at, is it -1 squared plus 1 will give us a 2. Wow. And 1 squared plus 1 will give us 2. And when x is 0 here, 0 squared plus 1 will give 1. Oh, we are there. So the rule is x squared plus 1. So -1 squared gives 1 plus 1 will give us a 2. 1 squared gives 1 plus 1 will give 2. 0 squared gives 0 plus 1 will give us a 1. So that is the rule of the mapping. Then we now look at B. Is the mapping 1 to 1? The mapping is not 1 to 1. So it is ruled out because the image of -1 is 2 as well as the image of 1. So it is not 1 to 1, but it is onto, because the codomain here is 1, 2, and the range is also 1, 2. So we conclude f is not 1 to 1, but it is onto. So we go to C. For C, we are to find the range of the mapping. We have already mentioned that it is the same thing as the codomain. So we have it as 1, 2. So with this, we have done justice to problem 3. We go to problem 4. For problem 4, we are to determine the range R of the function, which is given here. That's 3x plus 2. If d equal to -2, -1, 0, 1, 2 is the domain of the function defined on D. So we know the domain now, we are looking for the range. And our f of x is 3x plus 2. So to find the range, so we still remember from our denotation, f of x is equal to y. So we are looking for the images of all these elements in the domain. So we now put when x is -2, so we find f of -2, 3 times -2 plus 2, 3 times -2 gives -6 plus 2 gives -4. That is the first element in the range. Now when x is -1, we have f of -1 is equal to 3 into -1 plus 2. 3 into -1, that is 3 times -1 gives -3. -3 plus 2 gives -1. Then we look for f of 0. F of 0 now will be 3 into 0 plus 2, which will give us 2. Then we have f of 1, that's 3 into 1 plus 2, that will give us 5. And finally we look for f of 2, 3 into 2 plus 2, 3 times 2 gives 6 plus 2 gives 8. So we've gotten all the elements in the range of their function, so that we'll now have it as range equal to set of -4, -1, 2, 5, and 8. So that is the end of solution to problem 4. We go to problem 5. For problem 5, determine the domain D of the function h of x equal to x squared plus 2 if r is equal to 3, 6, and 11 is the range and h is defined on D, which is the domain. So this is the reverse process of problem 4. Here we know our f of x is x squared plus 2. In this case now, the meaning here is f of x is equal to 3, so which means x squared plus 2 is equal to 3. Then we solve this equation. So solving this, we have x squared is equal to 1. 3 minus 2 gives 1, where x is square root of 1, and this is going to give us positive or negative 1. We are taking the positive and the negative roots, so we have to be very careful with that. And the second element in the range, which means f of x is equal to 6, which means x squared plus 2 will be equal to 6. So solving this, take this to the right hand side, x squared will be equal to 4, and x is square root of 4, and that will give us positive and negative 2. Then the last one, f of x is equal to 11, that is x squared plus 2 is equal to 11. Then x squared will be 11 minus 2 gives 9, so x is square root of 9, which gives plus or minus 3. So we now collect the domain. Now for this domain, we have a d will be equal to, we first collect the negative element first, starting from negative 3, negative 2, and negative 1. Then the positive element will be 1, 2, and 3. This is the domain of this mapping. So we are done with problem 5. We go to problem 6. For problem 6, given that f of x is x squared plus bx plus q is a mapping defined on the set of real numbers, if f of 1 is equal to 2 and f of negative 1 is equal to 6, find the values of p and q. Here we look at, our f of x is x squared plus bx plus q. F of 1 is equal to 2 means 2 is an image of 1, where this 2 is in the codomain and 1 is in the domain of the mapping. Wherever we see x, now we put a 1 and then equate it to 2. If f of 1 is equal to 2, now we have a 1 squared plus p into 1 plus q, then it's equal to 2. If we take this to the other side, it becomes 2 minus 1, which will give us 1. P times 1 will give us a p plus q is equal to 1. So we can call this one equation 1 and use the other information to create the second equation and solve simultaneously. So we now have f of negative 1 is equal to 6. So we come to this function. Wherever we see x, we put negative 1. So negative 1 squared plus p into negative 1 plus q is equal to 6. This is also going to be 1. P times negative 1 gives negative p plus q. This 1 going to the other side becomes minus. So we now have 6 minus 1, which gives 5. Call this equation 2. Then we solve the equation simultaneously. We examine the coefficient of p in equation 1 and equation 2. The same thing. So since this one has the coefficient of p on both equations are the same sign, so we add equation 1 and 2. So p plus negative p gives 0, q plus q gives 2q, and 1 plus 5 gives 6. 2q is equal to 6, q is equal to 3. Now that we've gotten q, we can substitute in one of the equations to get the value of p. So from equation 1, p plus 3 is equal to 1 since q is 3. So we've substituted q to be equal to 3 in equation 1. So p now will be equal to negative 2. 3 going to this place becomes minus 1 minus 3 gives negative 2. So we've gotten the values of p and q in problem 6. So we go to problem 7. For problem 7, determine the zeros of the functions defined by a, f of x equal to 2x plus 5, b, f of x is equal to x squared minus 2x, and c, f of x equal to x squared minus 5x plus 6. From problem A, if f of x is equal to 0, then 2x plus 5 is equal to 0. We can then solve this linear equation. So we have 2x is equal to negative 5, and dividing both sides by 2, x is negative 2.5. So we go to B. If f of x is equal to 0, x squared minus 2x is equal to 0. That is, we can now solve this quadratic equation by factorizing this. X is common, so we have x into x minus 2 equal to 0, which means x is equal to 0, x minus 2 equal to 0. So solving this second part, x is 0, x is 2 are the zeros of the functions defined by x squared minus 2x. Now we go to C. For problem C, if f of x is equal to 0, x squared minus 5x plus 6 is equal to 0. This is a quadratic equation solving by factorization method. Since the coefficient of x squared here is 1, so I can have x in brackets, in two separate brackets. I then look for the factors of this constant term, which is positive 6. I am looking for two factors of positive 6 whose sum is the coefficient of x, that is the middle term, if it is expressed in standard form of quadratic equation. Now the two factors, immediately we can have 2 and 3, but 2 times 3 gives 6, right? But 2 plus 3 will not give negative 5. So what we do, we attach negative to both 2 and 3 such that negative 2 times negative 3 will give us positive 6, but negative 2 plus negative 3 will give us negative 5. So we have the negative 2 here and negative 3 here, which means x minus 2 is equal to 0, x minus 3 is equal to 0, and finally we have x is equal to 2, x is equal to 3. And that is the end of solution to problem 7, and invariably this is the end of this tutorial. I hope you enjoyed it. Please check the description section of this video on our YouTube channel to get links to our other videos on mappings and other topics. Until we come your way again, goodbye.